Okay, so let's have a quick look at this stuff.
Luke's here.
All right, Luke's here, excellent. Okay, this was the one that most people missed. Now I'll tell you why people missed this one too. They went about this in a tedious, non-productive way. Find the greatest real solution or the complex solution with the greatest, with the plus sign, right? So what people tended to do with this is they tended to want to expand this thing out, FOIL out the x minus 4, and then make this into a big ugly quadratic equation and then use quadratic formula. But that's not what we want to do. What's our strategy here? What should we do on this one?
I think that's what we want in here.
Yeah, maybe.
Subtract
But now, what's our strategy? If I can point to a single x, which I can do, right? Here's the single x. We isolate, yes, and that is so much easier. We're going to isolate that guy, right? And so to isolate, we go bottom up through order of operations and just follow those steps until we get x by itself. So first, can we add or subtract anything?
Subtract 13 from 3.
Yeah, good. Subtract 13 from both sides first, right? So step 1 is going to give us 6 times the quantity x minus 4 squared equals negative 10. Okay. Now what?
Multiply 6.
Divide by 6.
Okay, divide by 6. Don't expand. Remember, our goal is all we really want to do when we're isolating. Just think about this. See if you can build kind of a non-mathematical way of thinking about it. Think about it in terms of trying to, move stuff in an equation. I'm trying to just move everything away from the x to the other side. The equal sign is what separates, the two parts of the equation. I want to get that x by itself on the left side, so I'm going to gradually try to just move everything else away. And this is the order in which I have to do that. That's what the rules say. So if I divide both sides by 6, then after 2 steps, I end up with x minus 4 squared equals negative, yeah. And I don't want to make that a decimal though, because this would be a repeating decimal, and that's rounded. So I could reduce it if I wanted to 5/3, but even that's optional. Right? Okay, so we took care of that. Now what? Square root. Good, because now we get up to exponents, and I have an exponent right there that I have to get rid of. And the way I'm going to undo that is by square rooting both sides, right? And so step 3, if I square root the left side, what do I get? X minus 4. If I square root the right side, what do I get?
Square root of negative 5.
Okay, good. Square root of negative 5/3. Are we done?
And then the negative change to an I.
Okay, good, but there's something else we're missing. If I square root both sides, what do I always have to put in? Plus or minus, good. So I'm going to get a plus or minus. And then I've got this negative sign in there, which is going to turn into an I, isn't it? Good. So I'm going to end up with then x minus 4 equals plus or minus I times square root of 5/3. Good. And then last step.
You add 4 over.
Yeah. So finally we get down to the parentheses, and so now we've gotten down to what was originally in the parentheses, the x minus 4. Then the last step would just be to add 4 to both sides. And if I add 4, remember, it just goes in front of the plus or minus. So I get x equals 4 plus or minus I through there you go. Okay, and we want the plus sign. So
you just do 4 plus I.
Yep. So that's our answer. So for Moodle then, we would just say 4 plus I times square root 5/3.
Do you have to put the times over after the I?
No, you don't, but it's not a bad idea. Yeah. Or you can put the I at the end. Doesn't matter.
Oh yeah. I have a question about putting looking at, you told me I could put it the front or the back, it didn't matter. Like, did you fix those problems?
That one, your answer was wrong. On that one, your answer was, I checked that one, your answer was wrong.
Okay.
So it wasn't, I don't think it had anything to do with the eye.
Alright.
But I did check it.
Alright.
I think I maybe wrote your note on too. I can't remember. But anyway, we'll look at it. We'll look at it next time. Okay, make sense?
Yeah.
Okay?
Are we testing again today, or are we going on to town?
No, we're going to chapter 6. Going on
So
chapter
can
6.
we take the test, like, if we have time to go to the lab sometime throughout the day? Can we go, or do we have to take the test like 1 year?
You could, there will be times when, as long as I'm there, it's fine. I mean, there will be some times like during periods 5 through 7 that would work. You know, when I'm in geometry, I think there's a lot of times that could be making work. But otherwise, I'll just get people, until we get them all done, I'll just keep getting people into TA. I'll just have like, probably for a while, 3 days a week for hours for 2, just to get people to get this stuff made up. And it might take a week or 2 to do that, but we'll get it taken care of. All right, so what about this one? This was the second most commonly missed one. Okay, and these two problems kind of fight each other a little bit. They're both doing different things, and you don't want to confuse what they're doing. On this one, we're supposed to simplify this. We want to expand it and write it in standard form. So this one is different than the last one. In this case, we are going to FOIL everything out and add up like terms and do all that stuff. So if I've got y equals 8 times the quantity x minus 8 squared plus 11, and I want to write that in standard form, I am expanding or simplifying. So I'm using normal order of operations. This is normal, start with P, PEMDAS stuff. Only when we isolate do we go backwards, but we're not isolating. Right? We're just trying to rewrite that in standard form. So what's the first thing we do?
We do x minus.
Okay, x minus 8, and x minus 8 can't be simplified. So inside the parentheses, I can't do a thing. Exponents, aha. There is an exponent issue, isn't there? I've got this squared here. So I've got to take this, everything that's being squared, and I have to expand that out. In this case, that means FOIL, right? So I'm going to take the x minus 8 times x minus 8 and turn that into x squared minus 8x for the O, minus 8x for the I. That just combines to minus 16x for the O and the I. Plus 64. Good. And negative 8 times negative 8 is plus 64. Okay, now, so that's the exponent part, right? But I've still got this 8 that has to get multiplied by that whole thing. Everything that's in the box has to get multiplied by 8. So I need to have that.
Wait.
Go ahead.
Okay, so you have, you got x squared and then you put negative 8x, or negative 8 and then you made it to 16x.
Yeah, because
What's
if I
64 for?
because if I FOIL it out, I get first times first is x squared. The product of the outer terms is negative 8x. Inner terms is negative 8x. Those combine to negative 16x.
Okay.
And then last times last gives me positive
Okay.
64. Okay? Now I've got this 8 that I have to multiply by the whole thing. So does everybody see, and this is real important, that I have to have that x squared minus 16x plus 64 grouped. Has to be in parentheses, because it's still a quantity that has to be, 8 has to be multiplied all the way through it, right? And so then I've got that still, and I've got this plus 11 at the end. So we took care of the exponents. Now what?
Multiply.
Multiply. Okay, good. So when I multiply, that means in this case, if I multiply 8 times this quantity, doesn't that mean distribution? Right? So that's going to give me
8x squared minus 128x plus 5 squared.
Okay, and then out at the end, I've still got this plus 11. Okay, but that took care of the multiplication. Then last step,
Add 11.
yeah, add subtract, meaning like terms. So these guys get added together.
5.3.
And my final answer is 8x squared minus 128x
Plus 5.3.
523. And what were they asking for? They wanted the value of b. So what's b?
128.
Yeah.
128.
Did everybody see that? That it's negative 128? Right. B is the number that's being multiplied by x. Okay? Make sense?
Yeah.
Okay. Okay, what about this one? Solve the inequality. Okay, these, I can see, to me, these are probably the hardest ones, because there's so many weird steps to it. Okay. So on this one, I've got this, I want to solve the inequality x squared minus 6x plus 8 is greater than or equal to 0. Okay, so first of all, if I sketch that parabola, and remember, the best way to do this is just by sketching. Solve this by sketching. That's a parabola that opens up or down? Up. Okay, so there's a sketch of my parabola. Now, what does this part right here mean in terms of my parabola? I want, yes, Tim?
How did you determine that it opens up?
Because A is positive,
Okay.
okay? Because the coefficient of x squared is 1, which is positive. Now, what did we say this meant? If I want to know when is this parabola greater than or equal to 0 on my xy plane where I'm doing my sketch, what does that mean?
Wait, what's your question?
On the parabola is either going to be on or above the x-axis.
On or above the x-axis. I want to know, how do I interpret this part right here? I said that the quadratic expression, if I were to graph that function or sketch it, it's an upward opening parabola. But what I'm really asking about it is, when is that upward opening parabola greater than or equal to 0, right? Now remember what this is doing. All this equation is doing is calculating y values in the xy plane. And so we're really asking, when are the y values, when is this parabola? The way we interpret this is on or above the x-axis, right? And so if I graph, if this is the x-axis, then aren't I wanting these parts up there, right? So the tails of the function this time are the ones that are on, or not the loop in this case, because it's opening up. It's the tails that are on or above the x-axis, right? And so we're looking for x values though, right? And so the x values, if I squash this thing down and only focus on the x values, if I just squash this down in the xy plane onto the x-axis, what x values are we talking about? Well, we're talking about the x values that are outside of or including the x-intercepts, right? The ors on a boat in this case. So we already know what our answer is going to look like. Our answer is going to look like, for sure, this is an or compound inequality. This part over here is saying x is less than or equal to whatever that x-intercept is. -4. Or x is greater than or equal to whatever that x-intercept
Wait,
is.
how did you figure out it was an or?
Because whenever I'm graphing, whenever a compound inequality, the graph looks like two separate intervals. Remember, those are the oars on a boat, like the oars sticking out the side of a boat. That's an or.
Yeah, how do you figure it out it's two separate?
Because we wanted to know when the parabola, this upward opening parabola, was greater than or equal to 0, right? So when its graph is on or above the x-axis. Well, it's on or above the x-axis out there, right?
So if it was just greater than, would it be an and?
No, then it just wouldn't have included the equal signs on it. Those would have been open circles. Then it would have just been above the x-axis, right?
So when is it an and?
Okay, now it would have been an and if this parabola had opened down. Then it would have been an and because it would have opened up like this, right?
Okay.
And then above, on or above would have meant the loop of the parabola, which was between the x-intercepts. Or if this had said less than or equal to, for example, if we'd wanted to know when is this upward opening parabola on or below the x-axis, that would have been in between. Okay? So all I have to do then, the only part of this question, the sketch tells me everything except what are the specific x-intercepts. I just need to know what those are, and to find those, I just solve the quadratic equation, not the inequality, right? So we just go back and say, instead, x squared, I'll move this up in a second, minus 6x plus 8 equals 0, and solve that any way I want to. In this case, I could factor, couldn't I? Yes, sir.
It factor out as -4 and -2.
Yeah, the two numbers that multiply to +8 and add to -6 would be x minus 2 and x minus 4, right? But here's the other mistake people tend to make with this. Those aren't the answers, those are just the magic numbers. The answers are what I get when I set those factors equal to 0, right? I still have to apply the zero product property. When is this factor times this factor equal to 0? Well, when one or the other of those factors are actually 0. It's the only way I can multiply and get 0 is when I'm multiplying by 0, right? So then either x minus 2 equals 0 or x minus 4 equals 0, and so my solutions are actually 2
and 4.
or 4, right? And so now I can fill in the blanks. This one down here is at 2, because that's smaller than 4, and this one must be a 4. Right? So either x is less than or equal to 2, or x is greater than or equal to 4. Sure, yeah. Okay, we didn't get through all of them, but those were the main ones. Do you feel like you want to finish going through this review tomorrow before you take the test, or?
Yes.
Okay. Okay. All right, good enough. I'll put this up on YouTube today. I'll make sure everything's updated.